Hey, what's up, 8th grade? Mr. Catlin here helping out with your Lesson 3 homework. 6th period, it was really fast. We didn't really get to go over this very much, so this might help you. In 7th period, you didn't hear it all. But I'm not going to go back over it again. It's a pretty simple lesson. The whole idea is knowing the difference between a rational number and an irrational number. Okay, so in our own words, I know these aren't your words, but these are my words of how I know the difference between a rational number and an irrational number. Okay, so a rational number to me is a number you can write as a fraction, a over b, and their opposites. Okay, so that means that negative numbers are okay. Okay, so opposite means negatives are fine. So positive or negative numbers that can be written as fractions. They don't have to look a fraction, but they can be written as a fraction. Okay, so a over b means that we could write it as a numerator denominator pair. All right, positive or negative. Here's some examples to just kind of put you in the right frame of mind. It could be an improper fraction like this. It could be a regular number like the number 8. You could rewrite the number 8 as 16 over 2, right? As a fraction. So that's a rational number. And then you could also have numbers that are like decimals that are negative, like say 1.5. That's a rational number. We could write that as a fraction as negative 3 cut in half, right? So rational numbers can come in fraction form or decimal or regular whole number form. And they can even come in the form of square roots, as long as the square root that you're using comes out and that's as a perfect square, a whole number, which we're going to see here in irrational form. Okay, and which leads us to the last one. Irrational numbers are numbers that you can't write as a fraction. Okay, this is a number that can't be written as a fraction. Written as a fraction. A over b and opposites. So irrational numbers can be negatives as well. It's okay. But we can't write them as fractions. So examples of that are like the number pi. Pi is a decimal that goes on forever and never repeats. That's another definition that I saw some of you writing today. It's a decimal that goes on forever and never repeats. Other examples of rational number or irrational numbers are numbers like the square root of 2. If you try to find what number you can multiply by itself and get 2, we found out today there is no fraction that can do that. And it comes out as like 1.1442 something blah blah blah, and it's not a decimal that stops or ever repeats anything. It just goes forever and it doesn't repeat, just like pi. Okay, you can have negative versions of square roots as long as the negative's outside. Like the square root of negative 15 is irrational because root 16 is 4, but root 15 is a little bit less than 4. It's like 3.9 something that goes on forever. It's irrational. It doesn't have, there's no fraction version of it that we could write. And then I'll do one more example for you. Let's just say that you have square root of 10. Okay. A lot of people think, oh, that's a nice number. That should be rational. No, there's no number you can multiply by itself and get 10. So it's irrational. It would be really close to like 3.1. Like if I type it in, look at these numbers when I type them into the calculator. Root 2, negative root 15, and root 10. When I type them into the calculator, they're not very nice. If Desmos would actually work with me here and let me use it. There we go. Okay, so root 2, not a very nice number. Root 10, the one I was just talking about. See how it goes on forever and it doesn't ever repeat or stop anything. And then the other one that we did was negative root 15. Once again, ugly number, doesn't stop. It's negative, and that's okay. But there's no way to represent that as a fraction. We just don't have a way to do that. And that's what makes a rational number irrational. So that's all I got for you guys. I hope you are safe tonight in the storms and you get that homework ready to turn in for Friday because it's still going to be due even though I didn't see you 7th period. Later.